Okay, students, so welcome to my lecture one of FX classes, physics. So today we will study chapter 1, kinematics. See, our first chapter kinematics will be divided into 4 parts basically. Pre-requisites, the cleaner motion, projectile motion, fourth will be our relative motion. Okay, so today we will finish up with the prerequisites. And prerequisites is a thing that is very important for the understanding of the course. Okay, fine. So before I start anything, that is chapter 1, part 1. I have already told you part 1 is prerequisites. Before I start anything, you all have studied in class 9th about the rectilinear motion. So we must know the meaning of the chapter, that is kinematics. Most of the students doesn't know the meaning of kinematics, but they are very expert in that topic. So let us first know the meaning of kinematics. Kinematics means a topic which is deal with just the motion, means it is not studying its cause, it's simply the study of motion. And also you have studied in class 9 about the force or momentum, angular momentum, etc., which will also come in class 11th in detail. It includes the term mass, whereas when we are dealing with kinematics, mass never comes into play. So wherever mass comes into play, the scope always open for the cause, because the mass is basically a part of the body, and by studying the mass of the object we can easily determine that what is causing the movement to cause, what is the cause of movement, how much force is required, etc. We will study in the further chapters. So I won't waste any time. Let us start. So first thing that we should know is, since we will all deal in this chapter 1, we will completely deal with the motion. So we must know that what is in motion and what is not. So I am giving you some examples regarding it to clear you that how to classify a particular body is in motion or not. Okay, so see A, B, C, D, E, F, G. There are 7 objects that I have given to let you understand that what is the meaning of motion and rest. A is moving 30 radians per second, B is moving 40 kilometers per right towards left, C is having 2 meter per second towards right and 30 radian per second angular velocity. D is having an angular velocity of 360 radian per second and 40 meter per second and a linear velocity of 40 meter per second, whereas object E is at rest 0 meter per second and 0 radian per second. Object G is right moving towards right at 40 kilometer per hour, and F is rotating clockwise with 45 radian per second. So the first question, so this things most of students have assumed that the things that is written that I have told and it's always true, but actually the thing that you're thinking is absolutely false if you do not consider this O. That's why I have highlighted this. This is a origin. I have considered this as a frame of reference. This I have considered as a frame of reference. Considering this as a frame of reference, I have given the velocities of A, B, C, D, E, F and G. All I have written there considering this as a frame of reference. Okay. Now to let you understand better, I will describe these 7 objects in parts. Okay. So first of all, let's take the objects which is only about linear acceleration, because since this chapter deals with the linear velocity term, so I'm just going with the linear velocities one. So I am considering only object B and object G, only which is having linear velocity, nothing else, even not the rest one that I am saying. So 40 meter per 40 kilometer per hour and G 40 kilometer per hour. Then we can see this, that 40 kilometer per hour, one is moving towards right towards 40 kilometer per hour, and this is moving towards, sorry, this is moving towards right, B is moving towards left 40 kilometers per hour, whereas G is moving towards right 40 kilometers per hour. So by looking at the magnitude, we can say that they are moving with same speed. Yes, of course they are moving with same speed, but by just looking at the magnitude, we cannot determine that whether the body is in motion or whether it's rest. Since I am talking about with reference to O, then it's easily we can say that they are in motion. But if I consider this as a frame of reference, forget this, I have considered this as a frame of reference now. For B, object B I am considering as FOM. Temporary I have considered it as frame of reference. So if we consider B as a frame of reference, then G will be 80 km per hour, because this is moving 40 kilometers west and this is moving 40 kilometers this one. So 40 kilometers it is B and this is object B. Now I want to calculate the velocity of G. So it is G object. Both are moving 40 kilometers per hour. This is also 40 and this is also 40. So I have considered this as a frame of reference. So frame of reference is always considered as a still point, that is at rest. So considering this as a rest, what I have to do, I have to make this as 0. Okay, so it is moving, this is, if I consider this as negative and this as positive, so why can't I add 40 into it so that it is 0? It's just like simple mathematical equation. So I add 40 into it, I add plus 40 and it will become at 0. Okay, so since it has become 0 kilometer per hour, so what happened, this I have added 40, and as you know in mathematics we do in both the side of equation, so here also we will add plus 40. So if we consider B as a frame of reference, then this will be 40 plus 40, which is known as 80 kilometer per hour. Got it? So considering B as a frame of reference, G is moving 80 kilometers per hour, and consider O as a frame of reference, both are at motion, and consider B as a frame of reference, B is at rest and G is at motion. Okay, now I will just do little modification here, little modification. This, forget about this, I will just little modification I will do. I will now, what I will do is, this was object B which was moving towards let's assume this is moving towards left as 40 kilometers per hour, and G is also moving west at, that is, it's not clear, G is also moving rightwards with 40 kilometers per hour. So considering anything, we will say that B and G are at rest, because since if I will give you an example, if you and your friend are walking in a path, and if you are talking with each other and they are moving with same speed, then you will again they will I should use the word velocity instead of speed, because if you run in one direction and a friend moves in another direction with speed, same speeds, then it will be different. So if you're walking in a same, we can use the speed only if the same direction. So suppose we are moving in a same path in same direction with same speed, then you have often seen that the friend we are talking, though we both are in motion with respect to ground, but we seem that he is at rest and we can talk easily. Okay, so this also signifies that I'm just giving a practical example. This 40 kilometer per hour is towards the left, and this is also towards left, so it will be at rest. But in physics, there is nothing called qualitative analysis. We have to do quantitative analysis. Then only we can say that the qualitative analysis done by us is true. Okay, so let's do one thing. I will do one thing there. I am considering now B as same point. I am considering B as a frame of reference. So as I said that here I have considered this as in positive direction. Okay, no matter. So here what I will do is I have to make it 0. So what I should do, I should just minus subtract 40 from it, and it will be 0 kilometer per hour. Okay, but don't forget that since I have subtracted 40, here also we will subtract 40. Fine. So it will be 0 kilometer per hour. So quantitatively we have seen that both are at rest, isn't it? So it always depends on frame of reference that what you consider B and G. Okay, now I will move on to some complicated examples. The linear velocity I have talked enough, then now I will consider, let's consider any object H which is moving 30 radians per second. Okay, now I will observe, just focus, forget everything, just focus on these two objects A and H. Okay, A and H, these are the two objects A and H. Now it's simple, very easy. It depends on your choice. Since at that time also I have not given any restrictions, but according to SI standards we should consider left as a negative and right as a positive. But if we do not consider SI standards also, your answer will always come out to be true, provided that what you consider the symbol, you will use that symbol as your answer only. It should not be like that you have violated the SI conditions, and then while writing the answer you follow SI condition. If you have violated SI conditions, then take your own assumptions only, and then only it can true. But since I am just reference to a general public, so I will follow the SI conditions. This is moving, as you can see, this direction, it is moving anti-clockwise. So here I am considering clockwise as positive and anti-clockwise as negative. Okay, so this is, we can also write this as minus 30 radian per second. Can't we? Because I have considered this as positive and negative. And this 30 radian per second clockwise, so this I will write plus radian. Okay, now what I will do, wait, I will just consider A as a frame of reference now. Okay, now this is my frame of reference, this is my FOM. Till that time I have considered different object. Now forget about this, wait, I am just a bit confused. It was just for explaining the first point. This is a frame of reference. So here minus 30 and here plus 30. You don't have to do anything. Just follow the concepts of mathematics here. I always said that the frame of reference is always still. So what I have to do? I have to make it 0. So what I will do? Plus 30 radian plus second. Isn't it? And here also I will do plus 30. Plus 30. Fine. So what it will do, it will be 0 radian per second, means it is now now it is frame of reference. Now it is frame of reference. If you do not make such as if you do not make this condition true, if you do not make this condition, then if you consider this as a frame of reference, then your answer is absolutely your answer that will come will absolutely wrong, whose probability will be 1, that it will be absolutely wrong. Okay, so FOM, I have just make it as FOM by 0 radian per second. It also in question it will not be written that which you have to consider as an FOM, but you have to sort out with vigilance and intelligence that that how can we sort out that which is best for which is what if we which object should be considered as an FOM. Okay, so this I consider FOM. Now this will be this result will be 60 radian per second, and since it is plus means what I said, plus means clockwise, so this will be clockwise. Fine. So here I can say that if I consider A as a frame of reference, then H will move clockwise with 60 radian per second, isn't it? It's very easy. Now I will move on to the little more complicated examples that I have mentioned here. Now you have to just consider, now forget about all the objects that I have talked before, previous I have talked before. Wait. Okay. Now this object C and this was object B. Now consider now everything, forget everything, just focus on these two, C and D. Now our perspective will be to study C and D. Now many people might think complicated that it is having both this and the angular acceleration, angular velocity also, linear velocity also. No need to get confused, it's very easy. Just simply if you have understood the thing previously before, then it's as easy as that. It's just a child's play. See, what you have to do is, it's moving towards right means, and it is right means positive and left means negative. Fine, no issues. So if it is moving towards right, then it is 2 meter per second. Okay, I have considered right as a positive and right as a negative, and same here, anti-clockwise I have considered as a negative, anti-clockwise, and clockwise I have assumed to be positive. These are the first assumptions. First is this step. First step should be this, that you play any assumption, then only we will start with the question. Now let us assume this as a let us assume, okay, now I assume this as a frame of reference. Fine, I have considered D as a frame of reference, and here it is saying that it is moving theta direction, it is anti-clockwise, isn't it? 360 radians per second, and this is the linear velocity moving towards left, 40 meter per second. What we have to do is we have to just rub the signs. This I am just doing for simplification. After do expert, then no need of that. This was anti-clockwise, so what I will do, minus, no issues. And this was also towards left, so I will do minus. Okay, now it's still not my frame of reference. To make it a frame of reference, what I should do, this is the second object. Do one thing that minus 360, do plus 360 in that. Wait, I will use a different color. Do plus 360, and here do plus 40. So plus 40 minus 40 is 0, minus 360 plus 60 is 0. Okay, and same here, plus 360 means plus 360 to angular. Don't confuse, plus 60 angular means angular. Don't mix up with angular with linear. Okay, plus 360 means I will here do plus 360, and here plus 40. So our result is completed. This, since I have this I have since I make it 0, it is my FOM, it's my frame of reference. Now here my work is done. Now I have to focus on just this part. Your work is done here. You have work done. Now forget about this part. Forget about this. Now just focus on the answer part. See, it is 360 plus 30 means it is 390 radians per second. Okay, and it's plus 40 plus 2 means 42 meter per second. So our final answer is, considering D as a frame of reference, its new velocity will be 390 radian per second and for 42 meters per second. Fine. Okay, now I will just take just an example, just a practical life example. This is E and this is F, where I can denote this as a sun in our solar system, and this is my Earth. Okay, see, we consider normally Earth, the sun also moves by millimeters in few years, but we are considering this as a rest in terms of broad analysis. So we are considering sun as a rest, that is 0 meter per second and 0 radian per second. And here Earth is revolving also and rotating also. So I will do one thing that you have already done in class 9, but I will do it again. So it will clear your conceptions here. This I have considered, and this I know I have to find out its omega also, and I have to find out its linear velocity. Fine. Now we know that. Now here, this question I am doing just for the purpose of your conversion of your units. So the prerequisite is very important. Now I am removing this sun, and now we are because I have considered this as a frame of reference. Since it is a 0, I don't need to do anything. This is already at rest. It's very easy. So I am removing it. Wait, let me remove it. I consider this as a frame of reference, means I don't have to do anything. It's just plus 0 and plus 0, so that doesn't make any sense. So it's the same. So if we calculate the angular velocity and the linear velocity, then our answer will be final only, because sun was already at still a point, so it is at rest. Okay, now I have to calculate this. This is the question. This is just a question. I will give a challenging question at the last of class. If the interested student may perform, and if they do not get an answer, they may reply main command, and I will also you can also note down my number. My WhatsApp number 8619177219. If you have any doubts, any personal queries, you can just WhatsApp me the query. I will definitely reply. Just take your phone and just WhatsApp me this, and just write in that. Do you know that I am a YouTube viewer? So I will just understand, and then I will just reply to you in that WhatsApp forum only. So this is a nice thing. So at last I will again tell the phone number. Okay, now let's consider. Okay, now I have to find out the angular velocity of the Earth. Okay, so omega I need to find out. Don't think that this class might not be understood to those who don't know the basic concepts. So they can ignore this part, because I will teach everything twice in again this part, but I will go little quick in that, so that the students whose concepts are already clear, they don't suffer. So I will just do, and since this is a class 9th concept, so I suppose that most of you know this concept. Okay, now we know we know that Earth takes 360 rotation. I will just give the exact data and revolution, so that you will also know the exact results. We all know that our day is of 24 hours. That's just for the approximation purpose, but actually Earth revolves around the sun in 23 hours 57 minutes. Okay, I'm just giving you the exact data. That is also exact, but still precise as compared to other books and all. And the revolution period means the Earth, we consider 365 days in a in a normal year, and 366 days in a leap year. And don't forget that after every 400 years, that is 1600, that is after 400 years means in century years, that is 1500, 1600, 1700, that is considered only a leap year if it is divisible by 400, not 4. So most of the people also think that it is 365.25, but it's absolutely wrong, because they forget out the century years in which suppose 1500 is not a leap year, because 1500 divided by 4 doesn't comes out to be 0, remainder doesn't comes out at 0, so it is also not considered as leap year. Now the reason behind is that earth takes 365.25 days, means you all know 6 hours, okay. Because the earth takes 365 hours, sorry, 65 days, I'm really sorry for that, 365 days, I will write it again, 365 days, 5 hours, 48 minutes, 46 seconds, okay. So I will now all the calculations, this I have taken complex data so that your calculations part is absolutely clear. Now this is our given data, we know this, and what is to be calculated, always do this question, first write the given and what is to be calculated. I need the rotation in radians per second, okay, and the answer revolution in meter per second, that is the angular velocity, and this is the linear velocity, okay. So let us start. First of all, I will just consider on revolution rotation period. Rotation, I say that rotation should be compiled in radian per second. This should be in radian per second, and this should be in meter per second. These are the final units which is there. So ultimately we have to convert this into this. And wait, many of the things I might be thinking that how it is true. This is, remember, this is just a time. This is just a time. This is a time. It is just a time. So don't judge this by its linear or angular. Angular and linear comes by this. The day and night happens due to rotation, that is movement of angular velocity, and revolution occurs due to linear velocity, okay. And since the both are happening, you feel that the rotation and revolution both are happening at the same time, so you feel that earth is revolving as well as rotating, so it is following an elliptical path, little bit elliptical. We will study in that later in Kepler's law and all, you will study more in it. Let us not go deep into it, okay. So 57 minutes, now let us calculate. Sorry for the delay. So first of all, we need to convert it in seconds, okay, because it is in seconds. So first of all, we need to find out 23 hours 57 minutes is equal to how many seconds. We need to find out this, okay. So we all know that in one day how many seconds are there. You can calculate it also. In one day 86,400 seconds are there. It's a very basic concept. And in 3 minutes how many seconds are there? 180. So the calculation is as simple as that. 86,400 minus 180, which comes out to be 86,220. Wait, I will just verify also, so that I do not commit any silly mistakes in that. Because concept is more important, not the silly mistakes. Yes, it is 86,220. Okay, fine. So your half work is done. So we can say that it is revolving with 23 hours 57 minutes. Means it is taking 86,220 seconds. It is taking to complete one rotation, okay. Now many students might be confused that one rotation, that no unit is given, nothing is given, no issues, okay. Everyone knows that one rotation is 360 degree. There is no doubt in this concept, and you also know this concept that 360 degree is equal to 2 pi radian. Only remember this concept, and you will never face any issues to convert a degree seconds to radian per second. Okay, so 360 degree means 2 pi radian, so I can also write 360 degree is equal to 360 degree is 360 degree time taken is 86,200. So I will just rub it off and I will just write 2 pi. Fine, 2 pi, 2 pi radian in 86,220 seconds. So in 1 second it would be 2 pi upon 86220 radian per second, and your work is done. Your final calculations answer would be, it will be the answer would come out to be, this is the final answer. Final answer I am writing in blue color, 7.28 7.287 radian. I have done the approximation after 3 decimal spaces. Okay, so it is also approximate answer, 7.287 radian per second. This I have got the omega, and this is plus, no issues. And in astronomical terms, east to west is taken as the which rotates east to west and west to east. So earth rotates west to east, so this is taken as positive. And west to east, if I say that northwest is the west to east, west to east. Many people might be confused that west to east, how it is taken as positive, why it is not negative. It's as simple as that. West to east, we always rotate this way, like 60 degree, 90 degree, 120 degree, so it is west to east, means it's positive. And many other planets like Venus rotates east to west, so this is negative because it's anti-clockwise. So positive means clockwise, so it is 7.827 positive. Now our calculations for rotation is over. Now I am just focusing on revolution. Now here there is a little complex part, but it's easy if you understand the concept. It's so easy if you understand the concepts. So it is 365, it is 5 hours 48 minutes and 46 seconds. I need to convert into seconds and my work is done. Okay, so if I want to convert into seconds, so what I have to do, our basic purpose is to convert into seconds. Very easy. 365 into 86,400, one day how many seconds are there, plus 5 into 3,600 plus 48 into 60 plus 46. It's as simple as that, isn't it? So it is 365, it is 6,400 plus 5 into 3,600 plus 48 into 60 plus 46. It is equal to how many seconds? It's equal to 3155692 seconds. So now one more thing. Now we want to cover that how many meters it covers. That is elliptical part. Elliptical part I will teach you in Kepler's law, that it's slightly different. It's not 2 pi r. It's based on elliptical concepts, which we will study in mathematics also, conic sections, that how to calculate the circumference of ellipse. So assume that this quantity would always be given. This is a given quantity. In this, it is only a given quantity, and they will only say that the total revolution path, that is, they will, let's say, give any x data. This is x. This will be given. So the answer of ours will be x upon 3155696 meter per second. Fine, I got with this. And okay, so this is my Pre-Requisite 1 video, and I don't want to make it any longer one, because many people, I am sure many people might have got bored, because if I treat class long, then many people won't like it. So thank you, and I will start out with prerequisites 2 in next class.